In this video, we will see about Word2vec. Text processing in machine learning or deep learning requires the conversion of text to some numerical form because machine learning and deep learning models are mathematical models which requires numerical input. Therefore, we are supposed to convert the text into some numerical form. Word2vec is one of the technique to convert text into some vector representation. So for to perform vector representation, how can we consider? We'll see the basics of Word2vec. So let us consider an example of words. Here we have four different words: king, man, woman, queen. Okay. So for to represent these words, we are considering three different properties: richness, authority, and gender. Okay, when it comes to richness, the king is rich. King is rich. So the value for richness for the word king is 1. 1 represent rich, 0 represent not rich. Okay. So richness for property for king word is 1. And authority, king has authority. So here also 1 represents having authority, 0 represents no authority. Okay. So king is having authority. So even authority values, authority property is represented with value 1. Moving on to the gender. Here -1 represents the male gender and 1 represents the female gender. We considered it as -1 as male and +1 as female. Okay. So here king is male gender, so it's -1. Therefore, by considering these three properties for the word king, we made a vector 1, 1, -1. Here you can see the king can be represented with a 3D vector 1, 1, -1. In the same way, for man, man is not rich. He is not having any authority. He is a normal person. His gender is male gender, so -1. Woman, woman is not rich, is not having any authority, but her gender is female, so it's +1. At the same time, queen is equally rich with respect to king, right? Both king and queen are rich, so it's 1 for richness. And queen is also having authority, so again it's 1 for authority for word queen. And gender is female gender, so it is +1. Okay. So overall, the queen is represented with vector 1, 1, 1. So we consider three different properties, which means we are going to have three-dimensional vector to represent the words. So based on how many properties we are considering, we'll have that dimensional vector to represent a word. Okay. So what is the reason why we are going to convert this into vectors is to perform some mathematical operations, because we are having only mathematical models. We need to perform some mathematical operations. So here you can see we are performing some mathematical operations on words also by using these vectors. Okay, king minus man plus woman is equal to, by performing the mathematical operations, we are able to get the vector 1, 1, 1, which is nothing but queen. Okay, so we could able to perform the mathematical operations on the words also by using these vectors. So now we can tell these vectors can be used for further processing, right? These vectors are representing the words and these vectors can be used for further processing for understanding. Okay. So this way we are converting the words into some vector form. Here you can see the 2D plot By considering richness and gender as two different properties, we are representing these words in a 2D plot. Okay. Here you can see queen and woman are nearby and king and men are nearby in the 2D plot. Okay. So the similar words should be nearby and the opposite words should be far away in the space, which means this will allow us to capture even the semantics within the vector. So we are able to capture properly the semantics within the vector so that the similar words will be nearby and the on the opposite words will be far away. Okay. So in another, in TF-IDF or in bag of words, we are losing this information. We are losing this information, but in Word2vec, we can try to capture the semantics of the words so that uh, we could able to properly represent the word into the vector format or which can further process, which can get further processed. Okay. If we have another word, minister. For minister, for example, minister is not rich, so the richness value is 0, and minister is also having authority, so the authority value is 1, and the gender, if we consider male minister, the gender is -1. So here you can represent the word minister with 0 comma 1 comma -1. This is the vector to represent the word minister. Okay, but there are two issues. Okay, so first one is because we are having some 4 to 5 words, we have considered some 2 to 3 properties and we could able to represent the word into the vector format. This is fine manually. But if we have hundreds and thousands of words in our vocabulary, it is very difficult to get the properties and manually assigning the values. Okay, because it's a tedious task and we could not able to perform it completely. So that is one issue. And another point is simply we are considering yes or no in authority. If one represents the word is having authority, 0 represents the word is not having authority. Okay, so we are simply either 1 or 0. We are giving the value for authority. If you consider the word king and minister with respect to the property authority, both are getting value 1, right? But king is having more authority than minister. Okay, king is having more authority than minister. But with just 0 and 1, we cannot consider, we cannot differentiate the authority level between the minister and king, right? So we are supposed to consider the we are supposed to quantify their we are supposed to qualify their authority level. Okay, so for that purpose, if we have another value like 0.9, if we not only just yes or no, if we could able to keep more values like 0.9, then we can tell minister is having uh, authority to some extent, that is 90%, whereas king is having 100% authority. Okay, the level is varying. Therefore, so just presence or absence is not enough. We are supposed to have the values. Okay, we will consider the values also. I can simply I here I can simply replace 1 with 0.9. So the vector for minister is 0 comma 0.9 comma -1. Okay, but this is if we have a very small corpus with a limited amount of properties. But if we have thousands of words and different properties, actually getting the value to be represented is also very difficult. One single value is also difficult. So that we can perform the word to vec by considering neural network also, that we will see in the next video, where we have different approaches like SIBO and skipgram to convert word into the vector format. This is the manual format of converting word to a vector. For our basic understanding, we consider this manual example. In we have certain techniques like SIBO and skipgram, which uses a neural network to, it's not exactly neural network, it will consider certain, it is having only one layer in it. For SIBO and skipgram, it is having only one layer, and we could get different dimensional vector. I mean, not different exactly for all, we can have one single dimensional vector, and with different values we can get it. Therefore, we will be using SIBO and skipgram. That will that automatic process of extracting a word to vec instead of manual approach, we will see in the next video. Thanks for watching this video.